This is going to be, again, a pickup truck driving with a constant x velocity, 20 meters per second. Let's pretend that's you. You're in a truck bed, and you throw something upwards with an initial velocity or original velocity in the y of 58.8 meters per second. That's what the VO means, original velocity in the y. The VOX is the original velocity in the x, 20 meters per second. So what you need to realize is, hey, gravity can only work in one direction, the negative y. So what I need you to realize is 20 meters per second is going to be what allows you to calculate a distance in the x direction. But guess what it is not doing in the x direction, and that is accelerating. So that means the acceleration in the x is 0, which there should be a square there, but the 0 times a half is even half of nothing. When you square that, that becomes even more nothing. So that term goes away, and it's the velocity in the x times time. That's all you need to know to get a distance in the x. So it'll always be 20 meters per second times some quantity of time will give you wherever you are, some distance in the x. The y component, though, is what gravity plays with. That's an original velocity in the y, so we do have a number for that. Time will be a list of times that it gives you at 1/2. The acceleration, the y, is going to be negative 9.8 meters per second squared. That's gravity, and you multiply it by the t squared. So gravity plays with this, not this. So when you go to put numbers in here for your for the math for the homework, what you do to figure out the distance in the x is wherever the VOX is, put a 20, and the time just changes based on whatever time it's given. 1 second later, you're 20 meters away. 2 seconds later, you're 40 meters away, and so on, just in the x direction, not the truth in the y. The truth in the y is you got a VOY, 58.8 meters per second. Throw a 1 second in there for this t plus, which I called a negative because gravity is in the negative y. That's the one direction, the down. And I'm lazy. Half of 9.8, I'm just calling it 4.9. 1 squared or 2 squared or 3 squared. So you throw that in the calculator. The magic box tells you 53.9 meters away, and the y direction is where you are 1 second later. 98 meters away is where you are in the y direction 2 seconds later. So you just keep plugging those numbers in the calculator in the magic box, and what you end up with is a set of ordered pairs like your math teacher would tell you in math class. When time is 1 second, your x position is 20 meters, your y position is 53.9. Well, that's just an ordered pair, 20, 53.9. 2 seconds later, your x is 40, your y is 98. That's another ordered pair, 40, 98. And so what you end up with is, all you're doing is putting dots at 20 meters away and 53.9. Then you're at 40 meters away and 98. So this is what, 20, 54-ish. This is 40, 98. And you just keep putting dots in, and that parabola that it traces out is just the path of it on its trajectory through the air, okay? When you do the back side of this, it's the exact same thing. The only difference is you're shooting a monkey at a banana, and who hasn't done that? When you shoot a monkey at a banana, though, it told you it was 16 meters per second is the speed that the banana leaves the slingshot. And if that's the case, then what I need you to realize is you have another triangle with a VOX and a VOY, where you can turn that 16 at 53 degrees into original velocity in the x. It's just 16 cos 53 because it's adjacent. That's a ca. So the x component is 9.6. The y component is the sine, so that's 16 times the sine of 53 is 12.7. All right? So you can use these exact same numbers, 9.6 and 12.7, and put them back into this. Just change the 20 to 9.6 and change the 58.8 to 12.7. and you treat everything exactly the same because gravity doesn't discriminate against pickup trucks or monkeys or bananas or whatever it was you launched. Gravity treats everything the same. Physics loves you.